Hi friends. So in previous lecture we had I would say it was a ANN toolkit, and I brought that application element also. Probably that was something that has lined up our third lecture, that is AI ML based operator advisory system. You must have noticed that I was using the functions used in a operator advisory system that was developed, but then very recently some more thing got added. I'll talk about it. We have now the stage ready for developing an or proposing an operator support system very recently. That is when I wrote my book Risk Conscious Operation Management for Complex Engineering System. So I have presented that view. In short, it was basically train each transients separately. So let us see the introduction. The major point here is which we should discuss: the PRA knowledge. PRA provides the operating procedures. They provide the input for developing a operator support system, especially for emergency condition. Okay, and second aspect is data is coming online. So if data is not coming online, there are ways. If operator wants to give some input, many ANN they give some interaction. That means the system is made interactive if it wants some more input. But here, as far as possible, we have taken the online data, and PRA provides a very effective framework for developing the rules. That is number one. And PRA starts with identification of initiating events. What are the postulated initiating events that are there as part of safety report, traditional reports, and then that are as a part of PRA also. It is called postulated initiating event, and that we are using as a transient, because all these events they without giving much time, they happen in a transient manner, and that we are trying to solve through ANN. So transient, the list of PRA initiating event, and then the knowledge based system or rule based system where we do diagnostic module is available. We saw in the architecture in previous lecture. You can see that is completely coming from the fault tree, event tree that were developed, because fault tree tells why the top system failed, what are the reasons, second layer, 1, 2, 3, 4, these are the reasons. Then why this 1, 2, 3, 4, the third layer. So you get into the diagnostics, how DG has failed. It is low oil failure because low oil pressure was low. And that was an alarm in the control room. But why the low oil pump failed? So you will have so many. So it is basically deductive technology, that is a fault tree that is available, knowledge that is available, which is used in operator advisory system, and the knowledge from event tree, how during a scenario, if some system, so if all the systems they perform as intended, then it is not an emergency scenario. That it was only initiating event. Okay, so but if the system do not perform as intended, then also it may not be accident condition. There are some mitigation provision, backup provisions, but then all those backup system fails and all, then we call it as an emergency condition. So, and that's how the operator knowledge has been built using probabilistic risk assessment model. We'll show some fault tree, event tree here and try to get this continuity in this lecture. So there are two major components here: a prior training of ANN, postulated emergency scenario, and testing of the same in a plant simulator. This is a very good facility that has got that has been there in the in the plants, that if I have developed something, I can test it on a simulator. Of course, simulator is not a model, it is a model of the plant, it is not a plant. But then you have come one stage closer to the real time behavior of the system, and then a limited sense, like all the events are not, like power supply failure is a anticipated operational occurrence. So it happens at least once in a year. So we have opportunity to learn. So if I have opportunity to learn here, I can use that input in this, I can simulate this condition in simulator, and then I can simulate, next time I will put myself not in the closed room, I will put the same only one event for whether it is identifying in the real time control room also. So I will get confidence like ANN, which is anticipated transient, use one more transient identification, slowly build the system and implement in the control room in a phased manner. This is the strategy that is required. Deploying the trend algorithm in plant control room for identification of transients is one thing, and then the knowledge based system which comes is the second part. So now we are set to discuss an application example which we have developed very recently, and I have discussed it in my book, Risk Conscious Operations Management. So now I just discussed PSA knowledge from fault tree, event tree that we derive, but the thing is PRAs are built for safety of the plant or risk assessment of the plant. We must remember there is a reliability connotation also is there with the system. Plant should operate also. So there are two ways of looking at the for as far as the knowledge base being built. There are two ways. One is in risk assessment model also there are lot of reliability related aspects, like if a safety system or a pump which has started in a loss of coolant accident, whether it will operate for a stipulated time, reliability concept. Okay. If the component has failed, what is the unavailability associated with the average unavailability, we can talk about it, we can embed into our system. So reliability, availability in the context of safety that was available. Now plant transient itself talks about the plant reliability, which is available to us in the form of transient data. So that also comes, and maximum unavailability is caused by this transients. It could be non-safety related, routine. This information provides the information. So PRA in that sense provides a good information in terms of frequency of this initiating event for building a knowledge base for a system wherein reliability can also be extracted. Okay. And then 10% remaining aspect which are having higher intensity in terms of frequency of failure or plant disturbances that can be modeled into the system, and then that will be called something plant transient, not safety related transients, because that is the reliability that we are associating with this. So there are ways to incorporate reliability, availability. Of course, our decision will be based on the risk level also, that is safety. Safety is the overriding factor. Now, why this system is required? A simple question we are asking. The plant was like this. Plant was there. Output, input, output processes, input, output. Then status and trips monitor. Control room operator was observing it. This is a typical plant and control room interaction that is going on here. So it was going smooth. Operator will see something, he will take action. But then why this transient identification and EOP for fault diagnosis? EOP means emergency operating procedure. I have not used it. I am only using diagnostics and all. Emergency operating procedure for fault diagnosis. Okay. When we have these two, and we have automized plant transients were occurring here also, earlier also, but through a computer based system we have regularized and we are presenting it to the operator. This is a symbolic representation of an operator actually. Plan view, you can see how a human will look like. So this is what it is there. So that means earlier he was going through the trip alarm signal and all that. Now this is a backup to him. and it can be expected that 95% of the time it will meet its model and he can use it as an advisory. But one important difference you will see, this link is not complete, it is a virtual, because system doesn't operate in a closed loop. Here if we affect anything, it will operate in a closed loop with the plant. So I think this arrow should have been also two ways actually, ideally speaking. But since we are giving the a simplified representation of human machine interface, so we have used now. So this is the role here, as a role of a friend or a supporter or advisor, and then operator feels confidence. What he was thinking is matching here also. If it is not matching, he can check why my thought and this is not matching. Oh, he will say I have not taken this factor into account, or the training algorithm might be wrong, or diagnostic algorithm, he can give a feedback and that can be modified. So he can operate in a closed loop actually. So the experience of this particular thing. So now we got the answer why this is required. It is a redundant system. It doesn't go into the closed loop without disturbing it. It is like a operator aid support that is available in the rule. Second reason is it tends to reduce the cognitive load on the operator, when there is a emergency, because it doesn't get affected. So in that sense, it is enhancing the resilience of the operator in terms of having a friend in the control room. And the only question is, when these things are qualified, it should be tested on a simulator in phase 1, and then as and when we get confidence, they should be implemented into the control room also. Okay. Like now I was telling you how to build a knowledge, loss of offsite power, as I mentioned, frequency 1 in a year. So in nuclear parlance itself, it is called a anticipated operational occurrence. It will happen in the life, but loss of coolant accident may not happen. I would say may or may not. I will say 430 plants are operating. A complete loss of coolant accident is not nuclear power plants. They have been operating. It has not happened. There are plants in this where we have a total accumulated experience of almost like 70 or 80 or 100. No event has taken part. So that is something, but as a precautionary measure, those systems are built. But here, this type, as far as the operator support system is concerned, this frequency is very important. So this is one input that is available, that this type of situation we might come across at least annually, okay, around. And then my system's performance will deviate whether we go to these are the sequences that we are here. So if the shutdown cooling pump doesn't start, so we have to, what it says, we have to build a diagnostics on this system. If it is unsafe, so this is safe state, you can ignore it. But this particular accident sequence is a called unsafe state. So now we have to first is see enough redundancy in loss of offset power. Then emergency power supply system, that is this one, it has to be robust. You can see here 5 into 10 to minus 4, that is the kind of, that is very low probability we have here. If it is not there, redundancy, diversity can be employed. And then loop and reactor. If the plant doesn't trip, then it lends into the accident. So that means safety significance of this system will be 1, 2, and then this one will be 3. So likelihood and consequences are this. So I got a very good insight on building the knowledge base, and which knowledge, which module or which system I should invest my resources in developing algorithm. Like say for diesel generator algorithm, I think we would have been there in the, okay. So diesel generator, we have 2 diesel generator. There can be a third diesel generator. Now it should not fail. So our capacity should be 1 DG should be taking care of complete plant loads, and minimum 1 DG. So you have a lot of redundancy, and if you have a probability of 10 to minus 2 for 1 DG, common cause if you take, it will be less than 10 to around 10 to minus 4 or less than 10 to minus 3. If I take a factor of 0.04 or 5. So that is the kind of thing. Now here, compared to the thing I have shown earlier, this ANN is I was having one ANN for each pattern. Now, when you have a x and y matrix in 2 dimension, there is a chance of that data getting lost when I do ensemble training. So, why not we build a system wherein there are there is a NN for loss of offset power, reactor, this thing RTPR, this one loop, loss of regulation accident, loss of flow accident, loss of coolant accident. Why not we build a system for each one? It does not require resources. We have pattern, we have to convert those patterns into time domain. Earlier I was using a pattern as a static pattern. So, it is making my things more dynamic in the sense that data is coming over a period of time. So, prediction capability over a period of time also will increase. So, like this if you see. So, this particular configuration, so here there are accident condition, anticipated operation, loss of offset power I explained you, and normal operation. So, these are the situation in normal operation. So, I have made my NN robust when it is operating normal, when reactor trip but no consequences and shutdown condition. So, it occurred to us that this could be, and that is how I put it in my book, that this algorithm will be better and the integration can be done, a small integration can be done and diagnostic module can be actuated. Because ANN has been identified the transient, it has come from this route, let us say loss of offset power, it has come from this route. Now, I have to prepare myself for diagnostics. So, for diagnostics I have done some filtering and this thing and then the diagnostic module, and here earlier we used production module rules, but now there is a good progress on fuzzy knowledge based development, and it does not require that kind of a complex inference engine also. So, I showed the slide where there was an inference engine and all that, but this fuzzy logic, why fuzzy logic? Because it can absorb it can absorb the fuzzy data also in terms of 0 to 1. That means I can use expert opinion if I do not have a quantified data. It is a huge power for us. So, diagnostic module using fuzzy logic knowledge based system has been developed, which has been proposed in my book, and the consequences, least consequences, I am showing the increasing trend by color, serious consequences. So, as I was telling, LOCA will not happen in the life of the plant, but we have to be careful because you have a system which can in rarest of rare chance it can rupture. So, that is why a system has been built. Now, with this configuration, now a lot of ANN and all that, of course, this I have discussed with you, ANN many conditions, one ANN, there are n number of ANN, I think 14, and we have, and then I was telling you plant essential loads. I am talking about the case. Actually, my effort is to tell you how knowledge based module is built. We have DGA, controlling power supply, lubricating oil. So, if my diesel generator has failed, my diagnostic system will capture this information, how they can fail, subsystems. Okay? And for second DGA, DGB, there is a breaker, this information, if breaker is failed, suddenly simply signal will go. Under voltage can also be trapped here. So, all this thinking, though I am sure you whether you will be able to visualize or not, but I want to open this floodgate for generating the information to develop the knowledge base and transient identification module. And this is from my book, Artificial Intelligence based approach for operator support system in risk conscious operation management, risk reliability, this thing, Singapore actually. So, it was my presentation, I guess. So, that is what I had presented during one of the conference or a book. Okay, overview, operator advisory system, R&D work on development of operator advisory system. It has been done at a laboratory scale, but there is a huge resource required to get the required confidence for real time control room scenario. And then for us, we saw the role of AI in complex engineering system. operator advisory system is based on PRA. How PRA can feed the knowledge to us, so that we can build our robust. Because if I say risk is my priority, then PRA is the right framework for me to develop a knowledge based framework. ANN for transient identification and fuzzy rule for diagnostics are this thing we have seen. Strategy is critical to reducing the cognitive load on operator. If using sensor input to diagnose and predicting is at the core of the PHM, then so now we have moved from operator advisory system to we are talking about PHM, and that will be discussed in the next lecture, prognostics and health management.